Hi everyone, this is Mr. here, and in this video we're going to be looking at polyatomic ions. So what I have on screen right now is just a quick summary note that you might want to do when you have a chance. It just summarizes a lot of what we've done so far. So just to recap, what we looked at the other day was how to name and write formulas for ionic and also for molecular compounds. So ionic compounds are when we have a metal and a nonmetal. And one of these, the metal, is going to be a cation, positively charged, and the non-metal is typically going to be negatively charged, an anion. And the way you write the formula is you cross over, and if you have to, you reduce. There's no prefixes at all. When you name ionic compounds, you simply name them according to the metal, the non-metal, and you change the non-metal atom from "ene" to an "ide." For example, if I've got sodium and fluorine, my ionic compound would be sodium fluoride. Some of the metals have more than one potential valence charge. And for those, we typically use the stock method, which is using the Roman numerals. However, you should also be able to do the Latin method, where the us and ic endings, the suffixes, mean lower and higher respectively. So if you've got two possible charges, for example, copper or for tin or for lead, you'd say, for example, for copper, you'd say cuprous, cuprous oxide or cupric oxide, depending on which particular charge you have in that multivalent compound. Now, when it comes to the nonmetals, you have to use prefixes because the nonmetals form very different combinations. They don't really cross over very well, so you have to be very careful with them. So you do not cross over, you use prefixes, and you never reduce. And the prefixes, these are a list of them, you should be familiar with them. And remember, mono, you only use for the first prefix, or not for the first, for the second element. So for example, if I've got carbon dioxide, I don't say monocarbon dioxide, I say carbon dioxide. So the carbon, it's implied has one, and the di means two oxygens. And again, we have the ide ending. Well, let's look at some other types of ions. So what we have here are pictures of two polyatomic ions. And what polyatomic ions are, they're clumps or groups of atoms that stick together, and what they do is they they have an overall charge. So because you have an overall charge, they're called ions. Because there's many atoms, we call them polyatomic. So here are a couple of examples. We have nitrate ion. So we've got 3 oxygens and a nitrogen. So NO3 has an overall charge of 1 negative. Here's another one called phosphate. Remember this from last year. So phosphate ion. And the phosphate ion has 4 oxygens associated with the phosphorus, so PO4. And the charge is 3 negative. Now, you have to memorize the polyatomic ions and memorize their formula and their charge. There's no way around it because there's so much variability. But we'll show you some ways you can remember them. So here's the handout that you have, and this is just a quick recap of some of the polyatomic ions that you learned about last year. So we have nitrate, and nitrate is NO3, and it has a charge of -1. The next polyatomic is chlorate, so it has a chlorine surrounded by 3 oxygens, so ClO3. It also has a charge of -1. Then we've got carbonate, so we've got a carbon surrounded by 3 oxygens, and the charge here is 2 negative. Sulfate has 4 oxygens and a charge of 2 negative. Phosphorus, 4 oxygens with a charge of 3 negative. And you remember ammonium, not ammonia, but ammonium from last year. It consists of a nitrogen surrounded by hydrogens, has a formula of NH4 with a charge of +1. And finally, we have hydroxide, which is an oxygen and a hydrogen, has a charge of negative. Now, with these polyatomic ions, what happens with them is they act like any other anion when they're joined with a metal or a hydrogen. So let's look at an example here. So let's look at potassium carbonate here. So when I look at potassium carbonate, the very last one here, my cation is potassium with a charge of 1 positive. Carbonate, remember, is CO3 with a charge of 2 negative. And then you cross over, and when you cross over, we end up with 1 potassium and, or sorry, 2 potassium, so K2, and 1 carbonate. So there's my polyatomic salt, we say. It's a salt because it's a polyatomic that's associated with a metal. Now, what I'd like you to do is, remember before we had our summary note, we looked at the ionic and molecular compounds. I'd like you to do the same thing and add this to that note. So I'd like you to add the following: the polyatomic ions from before, nitrate, chlorate, carbonate, sulfate, phosphate. So these are from grade 10. I'd also to include ammonium, hydroxide, hydrogen peroxide, and manganese dioxide. So if you can do that, take a pause right now. So pause the video, and if you do that to your summary note. Okay, now that you've looked at the grade 10, we also have extra polyatomics that you need to know for grade 11. So in addition to chlorate, we also have to know these. So remember, chlorine, fluorine, bromine, and iodine, they are all in the halogen family. So if you know chlorate, you're going to know fluorate, bromate, and iodate. They all are very similar, and they all have a charge of 1 negative. So they're easy to remember. Silicate is very similar to carbonate. So you're going to have carbonate with a charge of 2 negative, CO3. This is SiO3, 2 negative as well. They're both in the same family. Now chromate and dichromate are similar. So we have to put two chromates together. They join through an oxygen here and to form this dichromate. So this one you simply have to memorize. And finally, this is very, very unusual. This is an acetate. Now an acetate looks like this. It has 3 hydrogens, and it has this extra carbon over here. I forgot the C in here, COO negative, and it looks like that. So this part here is my CH3 part, and this part here is my COO negative. Now what's different about the acetate is that you have to remember that when you put metals, instead of putting them first, they go at the end. So if I'm dealing with, say, sodium acetate, even though say sodium first, the sodium is written at the end here. So the cation goes there. If I've got, say, for example, calcium acetate, so you'd have this acetate ion over here, you'd have 2 of them, and you'd have the calcium. So it's very similar to the other polyatomics. However, the metal's always written right at the end here. Now, you need to have a way of remembering this. So one great way is remembering Nick. So Nick over here, he lives in Phoenix, and he loves clams, and he happens to be crossing at a crosswalk. So Nick the camel craved clam at a crosswalk in Phoenix. We're going to use this saying to help us remember what the formulas are for these particular polyatomics. So the first one here is N for nitrate. Then we have camel, so carbonate is going to be the next one. This is Cr, so chromate. Cl is going to be chlorate. We're going to write down the formula for chlorate. This long one is chromate, but it's double S. Remember, dichromate. And finally, Phoenix reminds us of phosphate. So how does this help us with the formulas? Well, here's what you do. You write down the first part of the formula, so do nitrogen and nitrate, carbon, carbonate, chromine and chromate, chlorine, another chromine, and then phosphorus here. Now what you do is you look at the number of consonants in each of these words. So here in Nick, I've got 1, 2, 3 consonants. That's going to tell you how many oxygens you have. Camel has 1, 2, 3, so 3 oxygens in carbonate. Chromate has 1, 2, 3, 4 consonants, so this formula is CrO4. Clam, 1, 2, 3, so it's going to be ClO3. Now this long one, we got 1, 2, 3, 4, 5, 6, 7 oxygens and 2 chromines. Remember the double S. And then Phoenix is 1, 2, 3, 4. So you have 4 oxygens there. Now, how about the charges? Well, to figure out the charges, you simply look at the number of vowels. I've got 1 vowel here, negative, 1 vowel, 2 vowels, so 2 negatives, 1, 2 vowel, so 2 negative for the charge, 1 vowel, so 1 charge for chlorate. Here we got 1, 2 vowels, so 2 negative, and Phoenix has 1, 2, 3, so 3 negatives. So again, the pattern was this. The number of consonants is equal to the number of oxygens, and the number of vowels equals the charge number. And they're all negative. So don't depend on this. You should really be memorizing these, but if you're stuck, you're in a pinch, you can quickly write this down and help you figure out the polyatomic that you might be forgetting. Okay, so what I'd like you to do on your previous summary chart, if you could add this information here somewhere. So next to the chlorate, write down fluorate, bromate, iodate. Remember, they're very similar. They're in the same family. Carbonate's very similar to silicates. You might want to write those together as well. Now, in addition, somewhere either at the top or at the bottom here, you might want to write down Nick the camel craved clam for supper at a crosswalk in Phoenix, and just remind yourself of what the number of vowels represent and what the number of consonants represent in that particular thing. So it's a great way of remembering. So what I would like you to do is, now that we've gone through the naming of these, so practice in this little chart, and then when you're done, go pause, and then when you're done, hit unpause and check your answers. So you should be checking your answers right now, and like before, you should be writing down the cation, the anion, then you cross over, and then you simply write down the formula for each of these. The only thing to keep in mind is that for the acetate, remember to keep the metal at the end. So that's it for polyatomic ions.